Hello guys, and then welcome to another video. In today's lesson we'll be talking about solution of differential equations. Okay, so from our previous lecture we got to know the introduction of differential equations. Okay, so we got to know the classification, and then we got to know that we have the ordinary differential equation and then the partial differential equation, right? And then we'll be focusing on the ordinary differential equation, because the partial differential equation will be treated in another semester or topic. Okay, so we also got to know the order, the degree, and then linear differential equation, but in this section we'll be talking about solution to differential equations. Okay, and then with this, by the close to the end of the video, I will tell you, or I will show you how you could go by this same question or a similar question, but not doing much of the manual work. Okay, once again, in case you are new to this channel, kindly subscribe. Okay, subscribe to the channel, subscribe to the channel, subscribe to the channel. Okay, and then after hitting on the subscribe button, kindly take note. Okay, and then switch on your bell icon, okay, your notification, so that you don't miss out on any uploaded video. Okay, so without much ado, let's just dive right into this video. Okay, so we'll be talking about how to find the solutions of a specific differential equation. Okay, so for this example, we could see that this is the exact differential equation, right? Yes, this is the exact differential equation. Okay, so this is how it works. This is how it works for finding the solution for differential equation. You will be given the solution to the differential equation, okay, and then you'll be required to find the corresponding differential equation that relates to the solution of the differential equation. Okay, I don't know whether you get it, but what I'm trying to say is that you'll be first given the solution to the differential equation, and then you'll be asked to find the differential equation that relates to that solution. Okay, yes, that's how it works. So without much ado, let's find out how you could find or prove the solution of this differential equation, right? Okay, so let's dive right into this one. First, you have to know that you've been given the solution, right? So you know that from here, you know that the solution, okay, is equal to this, right? Okay, we have this. Okay, yes. So from here, from this differential equation, we could see that we have the second order differential equation over here, right? And then we have our this y. Okay, we don't have our first order, we just have a second order. Okay, and then the degree is just 1. Okay, in case you don't understand what I'm trying to say right now, just go back to the first or previous video to learn or get abreast with the classification and then the degree and order of differential equations. Okay, the link could be in the description, or just go back to the channel and then you'll find the video over there. Okay, so first what we'll be doing is just to find the second differential of this expression. Okay, this y, we'll first find the second differential. Okay, so we will differentiate 2 times. Okay, finding the second differential means differentiate 2 times, finding the third means differentiate 3 times. Okay, so let's start with the first differential. Okay, so you can either represent this by dy dx or just y prime. Okay, yes. So when you differentiate e exponent x, you get minus e exponent x. Okay, and then when you differentiate a certain expression, just like a trigonometric expression like sin x, you end up with a cos x. Okay, so plus cos x. Okay, so this is the first differential. Okay, now let's take the second differential. So y prime prime. Okay, now when you differentiate e to the power minus x, you get, since this is already negative, okay, the negative will just multiply this negative, and then you get what? A positive value. Okay, that's -1 multiplied by -1 give us +1. So you have e exponent minus x. Okay, and then whenever you differentiate cos, you get negative sine x. Okay, whenever you differentiate cos x, you get a negative sine x. So we have negative sine x. Okay, right, so we are done. Okay, all you have to do is just substitute this expression into this differential equation. Okay, so we have this differential equation could be also written as y prime prime, and then we have y equal to 2 exponent minus x. So the trick is you have to let the left hand side of the expression, okay, the left hand side should be equal to the right hand side. Okay, that's how you prove for the solution of a differential equation. Okay, make sure that the left hand side is equal to the right hand side. So let's just substitute this into this expression. Okay, we are substituting this, the entire of this equation into the main differential equation. Okay, so we have y prime prime is this. Okay, so we have this y prime prime. Okay, so just substitute this in place of the whole of this. Okay, so we have e exponent minus x, okay, minus sine x. Okay, yes, so this represents y prime prime. Okay, the entire of this is y prime prime. Okay, and then we have y, this is our y. Okay, this is our y, so we have plus e of negative x, okay, plus sine of x, okay, and then this has to be equal to what? 2 e exponent minus x. Okay, so let's expand this expression. So we have, this is e exponent minus x, and this is positive e exponent minus x. This is negative x, negative sine x, okay, and then positive sine x. So this one will cancel this one. Okay, we'll be left with this one. Okay, so we have e exponent minus x plus e exponent minus x. This plus that will give us 2 e exponent minus x. Okay, and then this is our right hand side. Okay, we could see that the right hand side and the left hand side are equal. Okay, yes, this is how you prove for the solution of a differential equation. Okay, now without going through the entire calculation, you could just arrive at the same answer by just using a calculator trick. Okay, trust me, nobody will tell you this. Okay, they will just go through the traditional calculation. You first have to differentiate to get your answer. Okay, differentiate, or you do the substitution, and then you do the entire calculation to end up with the exact solution of the differential equation. But what if I told you could just use the calculator to arrive at the same answer? Okay, so we'll be doing that in a bit, but I would like to go through the calculation again so that it will be much clearer. Okay, so we have to prove for y equals this expression, okay, as a solution of this expression. Okay, yes, so all you have to do is to first take the second differential. Okay, so you differentiate 2 times. Okay, this is the y expression. Okay, so you first take your first differential, you get this, okay, plus this, then you take the second differential of the y prime. Okay, you are not taking the second differential for y, you are taking the second differential for y prime. Okay, so when you differentiate this y prime, you end up with this. Okay, so after that you just substitute your differentials, okay, into the main expression that's on the left hand side. Okay, so you have this and that, but you will be concentrated on okay, the squared y and then the x squared. Okay, that's where our concentration would be. So that's the second differential. So after taking the second differential, this is what we will get. So we just substitute the exact thing into our main expression. Okay, so d squared y on the x squared is the same as y prime prime. Okay, so you can just substitute that. So I simplified that into this form. So we have y prime prime is equal to this, so you just substitute that with this, okay, and then plus y. You know that y is this expression, okay, then you substitute that into this, okay, so equal to this, okay, equal to the 2e exponent x. So from here you could see that sine x will cancel sine x, and then we have e exponent x plus e exponent x. That will give us 2 minus x, 2 exponent minus x, and then this 2e exponent minus x is the same as this expression, okay. So to further prove your solution, you can just equate this to 0, and then you will find out that your main answer will be equal to 0, okay. You could do the same thing for this side. So this is what I'm trying to say, okay. So we have let's say this entire expression could be written as y prime prime, okay, plus y, and then minus 2e exponent minus x, okay, and this has to be equal to 0, okay. This expression has to be equal to 0, okay. So when you do the same thing for here, you end up getting the exact answer, okay. So we have 2e exponent minus x, okay, minus, because you'll be moving this one to this side, okay. So we have minus 2e exponent minus x, okay, then you end up with 0, okay. Means that they are equal, okay. That's the solution to the differential equation, okay. Now let's try to find the solution to the exact differential equation, but you'll be using a calculator. So you could notice that this first half of the tutorial is based on a theory based or a theory type question, okay. This is a theory type question. So whenever you see any question like this and then it's a theory question, this is how you go about it, okay. Yes, now I'm going to teach you how to do the same thing in case the question comes during your exam, but it will be a section A question, that's a multiple choice question, okay. So let's try the same thing with respect to multiple choice questions. So let's pick up our calculators, okay. Pick up your calculator, okay. Let's clear everything, and then let's clear everything, okay. Yes, so now what you have to do is that since this is your differential equation, okay, we could see that we first have the second differential, okay, that is the highest order, okay, that's the highest order of the differential equation. So all you have to do is just prove, okay, with your calculator, okay. So the first thing you would have to know is that you have to break every order into the first order, okay. What I'm trying to say is that whenever you get an expression with a differential equation and then the highest order of the differential equation is 4, okay, so you have to take the differential till you get to the first order, okay. So this is what I'm trying to say. You will see that this is second order differential equation, okay. So when you are trying to solve it per your calculator, okay, all you have to do is that you differentiate this expression till you get to this point, okay, till you get to this point, till you get to the first order differential, okay. So in case this was to be the third order, okay, you will differentiate it 2 times till you get to the first differential, okay, the first order differential, and then you use that expression for the calculator trick, okay. Again, whenever you've been given a differential equation, take time to differentiate till you get to the first order differential before you can use it on the calculator, okay. So now let's get right into this, okay. So pick up your calculator. So you just decrease this expression, okay, into its first order, okay, this exact expression into the first order, okay. So first take the first differential. Once you take the first differential, you end up with the first order, okay, right. So after that, you pick up your calculator, okay, and then you insert the exact expression, okay. But bear in mind that this is what we are trying to prove, okay. So you'll be using this, okay. So we have so the first differential is this, okay. So this is what you'll be doing. So first, after clearing everything, okay, you click on the shift, okay, and then you click on this, the differential or the integral expression, okay, click on this, okay, you end up with this expression, okay. Right, now you start punching this expression into your calculator, okay. So we have what? Minus e, okay, so you have this, okay, exponent minus x, right, and then we have minus, no, that's positive, so positive cos, okay, so cos x, okay, and then you close your brackets. Right, now this is what you have to do. Choose any reasonable value for your x, okay, choose any reasonable value for x. So let's choose 2, okay, value 2 for x, okay. This is our value for x. So after punching the first differential to your calculator, you choose a reasonable value for x, okay, and then you click on equal to sign. You see that this is your answer, okay. Now note that this answer is in degrees, okay, but we want our answer to be in radians, okay, because we have trigonometric expressions like cos, okay, so we want our answer to be in radians, okay. So all you have to do is that you change this degree answer into radians, okay. So click on shift mode and then you click on 4, okay, click on 4. After that, after doing that, and then you click on equal to sign again, okay. After clicking on the equal to sign, you will notice that the answer will change into radians, okay. Yes, so this is our answer, okay. Now you jot this one down. This is minus 0.77, okay. So we have the first differential, okay, to be minus 0.77, okay. Now this expression is equal to this value, okay. Now let's punch the y, okay, the y. So we have what? E exponent minus alpha x, okay, plus sine of what? Alpha x, okay. You use the same value, okay. So click on solve and then choose the value 2, because from the previous expression we used a value of 2, okay. Then you click on equal to sign and then you end up with 1.045, okay. Let's run this to 5, okay. So 1.045. so our y is equal to our value, okay, that's 1.045. so we have 1.045. so in short, this is what I'm trying to do. This is our expression, okay. So we are just representing this expression with values, okay. So this is what I'm trying to do, okay. So we have y prime plus y, okay, is equal to 2 exponents this, okay. So now we know this is the same as this expression, okay. This is the same as this expression. This is the same as that expression, okay. It's the same as this expression, okay. They are the same. Yes, they are the same. So this is what you do. So you found your value for this expression, okay. This is the value, and then you know y to be this, okay. Now we want to find the value for this, okay, because whenever we add these values, okay, whenever we add these values, they have to be equal to this value, okay. So the third step is to punch this one into the calculator again. So this is how you do it. So you have 2 alpha e, okay, then we have minus x, okay. Yes, note that we are still in radians, okay. So that's why we have r over here. whenever you are in degrees, you notice that the arrow will change to D. Okay, this is in radian, so the same value, okay, you just choose 2 again. Okay, now we could see that this value corresponds to 0.2706 or 0.271. okay, so now this value is equal to 0.271. okay, now this is the easiest part. All you have to do is just add this to this. Okay, add your y prime to the y, because that's what this side of the expression is trying to say. Okay, add this value 0.77, this is negative, okay, minus 0.77 plus 1.045. you'll notice that you'll get this value. Okay, so let's just check. Okay, so we have negative 0.77 plus 1.045. okay, let's check. Yes, because we could notice that we have the same value, or something very, very close to the same value. This means that this solution is the solution for this differential equation. Okay, this differential equation has a solution of y equals e exponent minus x plus sine x. This is how you see the question in the MCQ. You'll be given this expression. Okay, this will be the solution in the question, but this will be one of the options. Okay, this will be one of the options. Okay, yeah, so after going through what I just showed you, okay, you'll be able to find your answer without going through the calculation. Okay, so let me take this again. First, you have to first break the differential equation into its simplest order. That's the first order. Okay, have to break it down to the first order differential. Okay, after that you just substitute the first order into the exact equation. Okay, and then you use your calculator to get your answer, just like this. So all you have to know or do is that you have to keep your calculator in radians. Okay, especially whenever you are working with trig functions. Okay, keep your value or calculator in radians. Okay, that's all you have to do. Just punch the values and then insert your reasonable value. It could be 2, could be 3. Okay, it depends on you. So the value has to be very, very reasonable, then you end up with the exact answer. Okay, so this will be just an intro to solutions to differential equation. Kindly subscribe. Okay, subscribe so that you don't miss out on any trick, okay, or uploaded video or tutorial. Okay, and then like, share, and then let me know whenever in case you have any question pertaining to this video. Okay, in case you don't understand anything, just let me know in the comment section below, or you can just go through the video again and then you get to understand it. It's very, very simple and straightforward. Okay, so I will see you in the next video. Bye bye.